Morning, children. I hope you all are safe with your family. In chemistry, there are three important branches, namely organic chemistry, inorganic chemistry, and physical chemistry. Of course, many branches are there, but these three are very, very important. And among these three, organic chemistry in particular has played a vital role in improving the quality of human life. And many substances what we use in our daily life are nothing but chemical compounds. For example, the materials what we use for cleanliness such as soaps, detergents, even household bleach, toothpaste, etc. are all made up of chemical compounds only. Similarly, cloths what we use made up of cotton, wool, silk or terling we wear, and the dyes we use to brighten and beautify them are again made up of chemical compounds. Now during this corona period we are advised to use masks that is also made up of cloths, again chemical compounds only. Likewise, the food what we eat again consists of organic compounds. They contain carbohydrate, proteins, oils, fats, vitamins, etc. And most of the medicines what we use to protect us from diseases and ailments are all organic compounds. That is antibiotic what we use, some anti-malarial drugs, and then sulfur drugs, all are organic compounds only. Similarly, explosives, fuels, rocket propellants, everything are made up of chemicals only. So in a nutshell, we can safely say that chemistry has influenced our life so much that we don't even realize that we come across chemicals at every moment. In fact, we ourselves are beautiful chemical creations, and all our activities are controlled by chemicals. So today we discuss chemistry's role in our daily life. That is our 16th unit. Chemistry in everyday life, the contents are: number one is medicines. Under this you have to study about what are drugs or medicines, and then classification of drugs. Third one, how do drugs interact with the targets, that is drug target interaction. Then types of drugs. And the second topic is chemicals in food. Then third one is cleansing agents. So first we discuss about medicines. Number one is drugs. Under this drugs you have to study about what is drug, then classification of drug. The third one is drug target interaction, that is enzymes as a drug target and receptors as drug target, and then types of drugs available, and then chemicals used in food, and then cleansing agent. All these things we are going to discuss in this unit. First we take drugs. What are drugs? Ayurvedic and Unani systems of treatment of diseases have been used widely in the past, but nowadays these systems are virtually replaced by the very well, the modern allopathic system. In all these systems, drugs are used. They are chemical compounds of natural or synthetic origin. It is here where chemistry has played an important role in providing newer chemicals of synthetic origin which can be used for the treatment of diseases. Now, any disease, if you cure with the help of chemicals, it is called chemotherapy. So the chemical substances of natural or synthetic origin which are used for curing diseases and reducing suffering from pain are called medicines or drugs. And the branch of chemistry which deals with the treatment of diseases using suitable chemicals is known as chemotherapy. Now, so here the definition given: drugs or medicines, the chemical substances of natural or synthetic origin which are used for curing diseases and reducing the suffering from pain are called drugs or medicines. But some difference will be there between these two terms, drug and medicine. What is drug? It is also a chemical substance only which cures the disease but is habit forming, causes addiction, and has serious side effect. If you take a drug, then you will be addicted. For some days if you take the drug, then you become addicted. for that, and it has serious side effects. But medicine means it is a chemical substance which cures the disease. It is safe to use and has negligible toxicity and does not cause any addiction. Before we go to the classification of drugs, here I am showing some drugs what we use in our daily life, and here are the examples for the analgesics. They are painkillers. Next is anti-allergic drugs, that is antihistamine drugs. And this is antiseptic, what we use in our house, Dettol. It is antiseptic. Same manner Savlon we use. It is also antiseptic liquid. Next is, this is sulfur drug, antibacterial sulfur content drug, sulfur drugs. Now we discuss classification of drugs. Drugs can be classified in a number of different ways. Number one is on the basis of pharmacological effect. As the name suggests, this classification is based on the pharmacological effects of the drugs. It is more useful for the doctors because it provides them the whole range of drugs available for the treatment of a particular disease or infection. For example, analgesics reduce the pain, while antiseptics either kill or arrest the growth of the microorganism. So it gives the knowledge to the doctor. Second is on the basis of drug action. This classification is based on the action of a drug on a particular biochemical process. For example, all antihistamine inhibits the action of histamine, which causes the inflammation in the body. As there are various ways by which the action of histamine can be blocked. This is second classification. Third classification on the basis of chemical structure. Drugs have also been classified on the basis of their chemical structures because the drugs having common structural features often have the similar pharmacological activity. That means the drugs having the similar structures will have the similar effect on the particular disease. For example, all sulfonamides having a common structural features as given here are mostly antibacterial. So one drug is given sulfonamide. It has sulfonamide, sulfadiazine. These all have common structural unit. Common structural unit is there means their action also will be common. The next classification on the basis of the molecular target. Drugs usually interact with the biomolecules or biological macromolecules such as carbohydrates, proteins, nucleic acids and lipids. These are called target molecules or drug target. Very important board question. What is drug target? They will ask. And drugs possessing some common structural features may have the same mechanism of the action on a specific drug target. So this classification is most useful for the medicinal chemist. Now second topic is, so first topic is a drug, how they are classified. Number one is on the basis of pharmacological effect. Number two is on the basis of drug action. Third one is on the basis of chemical structure. Fourth one is on the basis of molecular target. Next topic is drug target interaction. How do they interact? Macromolecules of biological origin performs various functions in the body. And three important, the macromolecules here given are proteins, which perform the role of biological catalysts in the body are called enzymes. And those proteins which are crucial to communication system in the body are called receptors. All are proteins only. And those proteins which carry polar molecules across the membrane are called carrier proteins. So three important proteins given. One is enzyme, another is receptor, the third one is carrier protein. All are essential. Now, first one, you take enzymes as drug target. Catalytic action of enzyme. You know very well what are enzymes. Enzymes are biological catalysts. So the first function of an enzyme is what the enzyme will do. It holds the substrate. Substrate means reactant for a chemical reaction. And active sites, this is one enzyme. Suppose you take the active sites here marked. Active sites of the enzyme hold the substrate. Suppose this is your substrate, reactant is entering here. So what is the role of enzyme here? Enzymes are nothing but proteins only. Enzymes are nothing but biological catalysts, nothing but protein. So first function is the enzyme hold the substrate for chemical reaction, and the active sites of the enzyme hold this substrate molecule in a suitable position so that it can be attacked by the reagents effectively. The second function of the enzyme is to provide the functional groups that will attack the substrate and carry out the chemical reaction. Now on the surface of the enzyme, many active sites will be there and they contain functional groups. That functional groups will attack the substrate and carry out the chemical reaction. Two important actions of enzymes discussed already. The first function of enzyme is hold the substrate, that is reactant molecule, for a chemical reaction. The second function of enzyme is to provide the functional group which will attack the substrate to carry out the chemical reaction. Now we discuss about drug and enzyme interaction. Drug which inhibits any of the two activities of the enzyme are called enzyme inhibitors. Enzyme inhibitors can block the binding site, thereby preventing the binding site of the substrate to the active site and hence inhibiting the catalytic activity of the enzyme. Drugs inhibit the attachment of natural substrate on the active site of the enzyme in two different ways. And here the picture shows, this is your enzyme. Enzyme has active sites. Now the substrate is coming. Even suppose you take drug, that drug also coming there. So what will happen? Directly, instead of your substrate, your drug gets attached with your enzyme. So finally, the normal reaction is somewhat suppressed. And such drugs we call it as what? Enzyme inhibitors. And so the number one, the drugs which compete with the natural substrate for their attachment on the active site of the enzyme are called competitive inhibitors. And these drugs are called competitive inhibitors. And some drugs, they don't bind to the active site but bind to the different site of the enzyme, which is called allosteric site. Sometimes directly it will not attach with the your enzyme. Directly it will not enter there, but it occupies the other places and changes the surface of your enzyme, the active site of your enzyme. So the site occupied by the enzyme other than the active site is called allosteric site. And this binding of the drug at allosteric site, what will happen, it will not quietly sit in that place. It will change the shape of the active site of the enzyme in such a way that the natural substrate cannot recognize it. Such drugs are called non-competitive inhibitors. So there are two inhibitors, drug inhibitors. One is competitive inhibitor, another is non-competitive inhibitor. If the bond between an enzyme and a drug is a strong covalent bond which cannot be broken easily, then the enzyme is blocked permanently. The body then degrades the enzyme drug complex and synthesize the new enzyme. So this is the interaction between your drug and enzyme. Enzyme has active sites. Now the active sites may be occupied by your drug or it occupies the other sites. That site we call it as allosteric site. Then it changes the shape of your active site of your enzyme. So your substrate cannot recognize that active site. So finally the enzyme's action will be somewhat inhibited by the enzyme. I hope you understood this drug-enzyme interaction. Next is the receptors as drug targets. Receptors are nothing but proteins, I told already, which are crucial to the communication system in the body. Majority of these are embedded in the cell membranes in such a way that their small part possessing the active sites projects out projects out and opens on the outside region of the cell membrane. Here it is shown there outside the cell region of the cell membrane it is projected. And how do receptors transfer message to the cell? In the body, the message between the two neurons or between neurons and muscles is communicated through certain chemical substances called chemical messengers. And these chemical messengers are received at the binding site of the receptor protein. To accommodate these chemical messengers, the shape of the receptor protein changes a little and the messenger gives the message to the cell without entering the cell. And after the transfer of the message, the chemical messenger departs and the active site of the receptor protein returns to its original shape. In that way, the message is communicated. And two types of chemical messengers are, one is hormones, another is neurotransmitters. This biology students will study in detail. In the body, the message between the two neurons or that between neurons and muscles is communicated through certain chemical substances called chemical messengers. And these chemical messengers are received at the binding site of the receptor protein. To accommodate these chemical messengers, the shape of the receptor protein changes a little and the messenger gives the message to the cell without entering the cell. After the transfer of the message, the chemical messenger departs and the active site of the receptor protein returns to its original shape. This is chemical messenger, and this is cell membrane has the receptor, and the receptor is a protein and it has active sites. Now the chemical messenger is getting attached with that and the message is transferred. After that again it goes out and your receptor comes to its original position. And there are two types of chemical messengers. One is hormones, another is neurotransmitter. What are hormones? Hormones are a group of biomolecules which are produced in the endocrine glands. These enter the bloodstream and travel to the different parts of the body, activating all the receptors which recognize them for messenger transfer. They are not deactivated very quickly. Example, adrenaline. It is a hormone. It is released from adrenal medulla in situations of stress or danger. It prepares the body for physical exercise to bear the stress. Now next is neurotransmitter. Nerves transfer the message through neurotransmitters. And now coming to the drugs, how they reach the specific target. Both these receptors differ slightly in the structure of their active sites but still can bind epinephrine. Therefore, it is possible to design a drug which can bind better with one of the type of the adrenergic receptor than the other. Anyway, the types of receptors it is not given in your level, but you should know the types of the your enzyme. The receptor site with the drug. They are classified into two types. The drug is classified into two types. One is antagonist, another is agonist. Drugs that bind to the receptor site and inhibits its natural function are called antagonist. And these are useful when blocking of message is required. On the other hand, the drugs which mimics the natural chemical messenger by switching on the receptor are called agonist. So these are useful when there is a lack of natural chemical messengers in your body. So two types of drugs are there. One is antagonist, another is agonist. Next we discuss